Hi, everyone, and everyone online. My name is David Brown. I'm a principal with Bagot, and we're very excited to be here today to talk about our project. And just like everyone else, want to reiterate the thank yous to Andrew, Andy, John, Mitchell, and Omar for the invitation to participate this year and this and all the support that they gave us along the way. So first, I want to give a shout out to our team. These were the people from Bagot that worked on the project. Myself, Josh McCown here on my left, Amir Ashtiani and Haram Shem, who are unfortunately not able to join us today, and Ali Bear and Yulia, who are sitting in the audience watching us right now. So our objective was really to, similar to the first group, was to integrate, find a way to integrate PV panels into a rain screen facade system that could provide flexibility to be adapted to various building designs with different aesthetic outcomes, and to also to be able to optimize for a building's location orientation and provide the best kind of possible outcome for the performance of the photovoltaics. So in our initial research, we started looking at other kind of applications of photovoltaic integration in building facades, and we just maybe weren't very happy with sort of the visual appearance of it. The sort of lack of sort of integration, and also sometimes when integrated into glazing, some of the impacts it has on of the kind of visual of the glass, and sort of using terracotta, we thought there was an opportunity to provide more richness maybe than what we've seen, and just sort of a better kind of visual outcome and integration into the building. So we started by looking at a couple of different ideas. The first was actually looking at kind of this idea of the horizontal louver, where essentially you would use the terracotta panel on the underside so that when you look up the building, you primarily see terracotta, but then the top of the louver would be the photovoltaic that would be kind of properly oriented for the solar orientation of the building. So that was kind of exciting to us. And we got sort of interested in this idea initially of using wire cut panels so that we could actually improve the efficiency of the terracotta, and sort of using a kind of simple, straightforward extruded process, slicing it and using that kind of texture that would be revealed to kind of create some different aesthetic outcomes for it. And that we thought we could use it sort of in a wall application and a louver application. There was a lot of different sort of ideas we had at that point. But we sort of ended up studying this idea of integrating it into a more of a three-dimensional panel, where it's essentially kind of a tessellated facade system where the photovoltaic would be sort of rotated and oriented properly towards its orientation, and the PV panel would be, the terracotta would be the element that would sort of bring it back to the facade in a way. So if we kept the sort of building facade planar, the sort of translation to the photovoltaic became the kind of design opportunity with the terracotta. So one of the things that we liked about this was the idea that using this kind of tessellated system, you could come up with a lot of different patterns and approaches. So anything from purely orthogonal to these kind of more skewed rhombus shapes that we explored in diamond shapes. So we thought there was a lot of sort of design flexibility that it could be applied across a lot of different sort of building designs. There's just some further study of this kind of in model form, where we were looking, first at sort of just the pattern, but also how these patterns, this kind of folding technique can be used to apply to more organic building shapes, and could sort of be very versatile in its application. This is, as we kind of further develop the 3D panels, this idea that if you start with the kind of quadrilateral kind of outline, keeping it sort of planar, rotating the PV cell to a kind of its proper orientation, and then through that you start to get these kind of ruled surface geometries of the terracotta that become kind of exciting things to kind of create more depth and shadow in the facade, create opportunities to, similar to the first group, to almost have a self-reflection back onto the PV panel and increase its performance, and a lot of different sort of opportunities for different surface treatments and colors in the terracotta panel. So this was sort of the final sort of form that we'd sort of developed further for the mock-up. And again, just sort of this idea that it could be applied not only on sort of a kind of orthogonal building, but across, sort of more three-dimensional forms, using obviously CNC fabrication techniques to kind of create more versatility in the prototyping. So we did a case study. We took one of our projects, which is the Amberley in Brooklyn, and it actually was originally designed to be terracotta as well, to kind of integrate it into the kind of vernacular architecture of Brooklyn. And we started to kind of think about, what if we kind of reimagine this as this integrated photovoltaic sort of skin that will start to get kind of a bit more depth and texture than the sort of, let's say, the existing building. So we started off by looking at the solar analysis, kind of researching, using kind of similar tools, I think Bumblebee and Radiance to basically to understand the performance of the facade. South facing being here, the one that's the most orange, as you can imagine. East and west kind of having a little bit less light, and the north at this stage, at this particular moment, not getting any. But the idea that we could sort of craft the facades differently to kind of angle more towards the sun would also give the building a different reading as you start to move around it. We started to kind of look at what different, the different sort of orientation, the impact it would have on the solar radiation. So here you kind of see three different sort of rotations of the panels and how much radiation they're getting. So we use that to help optimize it for the facade application. And then finally, we compared it essentially to what would happen if we just did a sort of more normative kind of vertical flat panel of photovoltaic. And what we found was really exciting. By rotating the PV panel, we're actually able to get 50% more radiation while using 30% of the same surface area. So we're seeing almost a kind of 5 times better performance over sort of a more traditional vertical panel application. And then the other kind of thing that we thought was interesting about this is that through sort of dissipating the reflections of the building, there's a possibility of also sort of mitigating the urban heat island effect, having less reflection back down to the ground level and sort of dissipating that reflection as it's coming down. So this is just some of the views of this kind of using these three-dimensional panels on the building. You start to get kind of more texture, more relief, more more of a connection to the human scale. And this is looking kind of up the building. We looked at it at different times of day. These were just sort of our favorites, and you're starting to get this really interesting effect of the kind of iridescence of the glaze and the way that it reflects light and the kind of sort of gradient of different colors across the surface. So kind of I'll move into the mock-up now. Sure. So I'm gonna hand over to Josh for this.
Sure. So we did not get the chance to delve as deeply as our friends at BKSK did on the PV panel, but so we ended up kind of with our faux PV panel. But yeah, ultimately we kind of worked with the surface texture on the terracotta panel to kind of try and highlight the geometry shifts. And as we were talking to some of the students from NC State earlier today, they brought up the idea that could also be used to further kind of reflect the light on the PV panel, similar to the BKSK scheme, which we thought was pretty compelling as well. And these are just some early renderings that we did as part of the process. And mock-up. What's that? Oh yeah, one part that we didn't ultimately get to install was the corner panel, just due to fabrication and time. But the idea, generally speaking, is that's it's a solid panel without the PV that then gets cleaved and can fill in the corners and turn corners and that sort of thing. And then we've just got some more technical drawings of the system and some glaze studies, which we had a lot of time, a lot of fun working on that with Andy and Andrew from Boston Valley. And it's kind of funny that we somehow ended up with a very similar glaze technique that that BKSK did as well. And these are just some process images from while Andy was putting the panels together. And yeah, this is some process photos from the week. I think this is it. Yeah, and once again, just thank you everybody for having us. This has been a great time.